Good morning, students. In this class, we are going to discuss about the next concept in the redox reaction, that is types of redox reactions. Types of redox reactions. Here, we are going to study the 4 types of redox reactions. What are those? First one is combination redox reactions. Second one is decomposition redox reactions. Third one is displacement redox reactions, and the last one we are going to study, that is disproportionation redox reaction. Redox reactions. Now, here 4 types of redox reaction we are going to discuss in this class. First one is combination redox reaction. Second one is decomposition redox reactions. Third one is displacement redox reactions, and the last one is disproportionation redox reactions. We will discuss one by one. Before that one, already we have discussed the first 3 reactions in the 10th class only, that is types of chemical reactions. We have studied already in the 10th class only. In that we have studied combination reactions, decomposition reactions, displacement reactions also we have studied the double displacement reaction, and also the redox reactions we have studied there only. But now we are going to discuss about the types of redox reactions. In that we are going to study these 4, that is combination redox reaction, decomposition redox reactions, displacement redox reactions, and the last one is, this is new one, that is disproportionation redox reaction. We will start one by one. First we will start with the combination redox reactions. Now we will see what is meant by combination redox reactions. For that one, I am taking one rough paper. Here I am using one of the rough paper. Now just to check, we are started with first one, that is combination redox reaction. Now just to check a rough work here. First, you came to know what is meant by oxidation, what is meant by reduction in terms of oxidation number. That already we have discussed. Now, what is meant by oxidation? Increase in oxidation number. Increase in what? Oxidation number. If the oxidation number increases, that is called as what? Oxidation. For example, -2 to +3, right? -2 to +3. Oxidation number increased or decreased? Increased. That is called as what? Oxidation. For example, 0 to +1. Here also oxidation number increased from 0 to +1. Therefore, it is also called as what? Oxidation. Now, what is meant by reduction is decrease in oxidation number. Decrease in oxidation number. If the oxidation number decreases, then that is called as what? Reduction. For example, 0 to -2. Oxidation number is changing from 0 to -2. That is oxidation number is decreased. Therefore, it is called as what? Reduction. Or for example, +2 to 0. Here oxidation number is decreased from +2 to 0. Therefore, it is also called as what? Reduction. Just remember, oxidation means what? Increase in the oxidation number, and reduction means decrease in the oxidation number. If the oxidation number increases, that is called oxidation. If the oxidation number decreases, that is called reduction. Clear? This is a basic. Now we are discussing about what? Combination redox reaction. We will discuss about that one. For example, for first one, that is combination redox reaction, I am taking examples, right? Combination redox reaction. Just think. Now, what is meant by combination? Already you know what is meant by combination, right? For example, just remember, in a chemical reaction, 2 things are there. always reactant converts into the product. Reactants left side of the arrow, product right side of the arrow. It is also basic, right? In a chemical reaction there are two main things are there. One is called reactant, it may be one or more, and another thing is product, it may be one or more. Reactant always left side of the arrow mark, product always right side of the arrow mark. Reactant undergoes into changes and the products are the newly formed compounds in the reaction, right? Now just remember, left side of the arrow are reactant, right side of the arrow are product. For combination reaction, for example, now we will take the basic example first, general example. A plus B, these two are reactants. A is one of the reactant and B is another reactant. A is one reactant, B is another reactant, both combines and there is a formation of product AB. This is an example for which reaction? Combination reaction. Here next another example, A plus B plus C. Here how many reactants are there? Three reactants. A is one reactant, B is another reactant, C is another reactant. If all these three combines and there is a formation of product ABC, here AB is combined, here ABC are combined. Next, for example, X plus Y gives rise to XY, and for example X plus Y plus Z gives rise to XYZ. All these are combination reactions. All these are what? Combination reactions. Why I am calling all these are combination reactions? Because here two reactants A and B are combining and forming the product AB. Here three reactants A, B, C are combining and forming the product ABC. Right here two reactants X and Y combining and forming the product XY. Here three reactants X, Y, Z are combining and forming the product XYZ. Now just check here. Now just check here. In all reactions, how many reactants are there and how many products are there? Just count. Here how many reactants are there? 2. Here how many reactants are there? 1, 2, 3. Here how many reactants are there? 2. Here how many reactants are there? 1, 2, 3. Maybe reactants 2 or sometimes more than 2. In all combination reactions, if you count the number of reactants, you will get minimum 2 or more than 2. Means 2 or more reactants should be there in the combination reactions. If only one reactant if you take, that is not combination reaction. One element itself do not combine, correct? It should have to combine with other element, right? Therefore here minimum 2 reactants or more than 2 reactants are required for the combination reaction. And if we check the number of products in the all combination reactions, here how many product? 1. 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 Here one product, that is AB. Here one product, that is ABC. Here also one product, that is XY. Here also one product, that is XYZ. Means how many products are there? One product. Means in the combination reactions always 2 or more reactants combine. Here it is combine. Here also it is combine. Here also combine, here also combine. In the combination reactions, 2 or more reactants combine to form the one product or single product. Such type of reactions are called as what? Combination reactions. Just check here, 2 reactants are combining, forming only one product. Here 3 reactants are combining, forming only one product. Here again 2 reactants are combining, forming one product. Here 3 reactants are combining, forming one product. Means 2 or more reactants combines to form only one product. Such type of reactions are called as what? Combination reactions. Combination reactions. I'm not telling that that is combination redox reaction. I'm telling that that is combination reaction. Combination redox reaction means what? Here one element should undergoes into oxidation, another element should undergoes into reduction. One element should undergoes into oxidation, another element should undergoes into reduction. Here one element is oxidation, another element is reduction. Therefore again it is called as what? Redox reaction. Which type of reaction it is? Combination reaction. Again which type it is? One is undergoing into oxidation, another one is undergoing into reduction. Means it is redox reaction. Such type of reactions are called as what? Combination redox reactions. Right? Now that is only I am writing here definition. Now what is the definition? When minimum 2 or more reactants, sometimes it is also called substances. 2 or more reactants or substances, what they are undergoing? Combine. when two or more reactants or substances combine to form one product, to form one product or substance, one product or one substance. Such type of reactions are called as what? Combination reactions. What is meant by combination reactions? The reactions in which, right, two or more reactants combines and form only one product or substance. Such reactions are called combination redox reactions. Right, this is the definition for the combination redox reaction. Just remember, when two or more reactants combines and forms only one product, such type of reactions are called as what? Combination redox reactions. Now we will take the particular examples. Up to now we have discussed the general example. Now we will discuss the particular examples for combination redox reaction. Example. Now just to check, here I am writing the example. First example, here general example is A plus B gives rise to AB, or A plus B plus C gives rise to ABC. That is, reactants are sorry, here reactants are two or more, but product should be only one. Such type of reactions are called as what? Combination redox reactions. Now particular examples I am taking here. For that one I am using another pen. Particular example, this is general example I wrote here. Now particular example is carbon plus oxygen gives rise to carbon dioxide. Right, here one reactant, two reactants are combining and forming how many products? One. Here two reactants, one is carbon another one is oxygen, and only one product, that is carbon dioxide. Here what is the oxidation number of this carbon? Here it is 0. Oxidation number of this carbon is how much? 0. Whereas oxidation number of oxygen is also 0, because elemental state, only one element, oxidation number is 0. Only one element, oxidation number is 0. Whereas here if you calculate the oxidation number of carbon, you will get +4. Yeah, already we know that oxidation number is always -2, other than peroxides and superoxides, right? Now here carbon oxidation number is changes from 0 to, carbon oxidation number in the reactant is 0, in the product is how much? +4. That is, carbon's oxidation number is changes from 0 to +4, right? Oxidation number is increased, therefore it is called as what? Oxidation number increased means it is called as what? Oxidation. It is called as what? Oxidation. Now whereas oxygen, for oxygen, just here oxidation number of oxygen is 0, right? 2. Here oxidation number is -2, right? That is, oxygen's oxidation number is changing from 0 to -2, that is, oxidation number is decreased. Decreased means it is called as what? Reduction. Here carbon is undergoing into oxidation and oxygen is undergoing into the reduction. One element is undergoing into the oxidation, another element is undergoing into the reduction, and here more than one reactant is there and only one product is there. Therefore such type of reactions are called as what? Combination redox reactions. This is redox reaction because one carbon undergoes into the oxidation and oxygen undergoes into the reduction. One element undergoes into oxidation, another element undergoes into reduction. Therefore it is redox reaction. Which type of redox reaction it is? Again, combination redox reaction, because two reactants are there, only one product, means here two reactants are combining and formation of only one product. Therefore such type of reactions are called as what? Combination redox reaction. I will write another example. This is example 1, example 2. Let us take another example. Now 3Mg plus N2 gives rise to Mg3N2, right? Here it is. Now just check, if you calculate the oxidation number of magnesium, here it is 0, nitrogen 0, because elemental state, only one element means what is the oxidation number? 0. Only one element means what is the oxidation number? 0. If you check the oxidation number, second group, correct, that is alkaline earth metal, what is the oxidation number? +2. Here nitrogen oxidation number, if you calculate, it will be -3. Now for magnesium, just to check for magnesium. For magnesium, what is the oxidation number? From where to where it is changing? 0 to plus 2. Reactant, what is the oxidation number of magnesium? 0. Product, what is the oxidation number? Plus 2. That is magnesium oxidation number is changing from 0 to plus 2. 0 to plus 2. Whereas nitrogen N2 oxidation number changes from 0. In the reactant, 0. Here oxidation number of nitrogen is 0. Whereas in the product, what is the oxidation number of nitrogen? Minus 3. That is, it is changing from 0 to minus 3. Right? If you check here, magnesium oxidation number is increasing. That is 0 to plus 2. Magnesium oxidation number is increasing from where to where? 0 to plus 2. 0 to plus 2. Therefore, magnesium undergoes into which reaction? Oxidation. Already I told, increase in the oxidation number is called as what? Oxidation. Decrease in the oxidation number is called as what? Reduction. Whereas nitrogen's oxidation number is changing from 0 to minus 3. 0 to minus 3. That is, oxidation number is decreased. Oxidation number is decreased means it is undergoing into which reaction? Reduction. In this reaction, in this second particular reaction, magnesium undergoing into oxidation and nitrogen undergoing into reduction. Magnesium undergoing into oxidation and the nitrogen undergoing into the reduction. Therefore, it is an example for the redox reaction. It is an example for which reaction? Redox reaction. Again, which type of redox reaction? Just to check. How many reactants are there? 2 reactants. And how many products are there? 1 product. How this product is forming? By the combination of these 2 reactants, this product is forming. Therefore, which type of reaction it is? Combination redox reaction. These 2 are the particular example for the combination redox reaction. Just remember, combination redox reaction means what? 2 or more reactants, only 1 product. 2 or more reactants, only 1 product. Such type of reactions are called as what? Combination redox reactions. Right? Now we will go for the second one. First one over, second one, that is decomposition redox reaction. Now we will go for that one. For that one, I am using another paper. Second one I am writing. Second one. Which one is second one? Decomposition redox reactions. Decomposition redox reactions. Now we will see what is meant by decomposition redox reactions. For that one, I am taking one of the rough paper again. Now rough paper again I am taking here. Now just check here. Now decomposition redox reaction is exactly opposite to that of the combination redox reaction. Decomposition redox reaction is exactly opposite to that of combination redox reaction. Now, how it is exactly opposite means, in the combination redox reaction, how many reactants are there? 2 or more. But how many products are there? 1. Here it will be opposite, exactly opposite. That is, only 1 reactant, 2 or more products. Such type of reactions are called as what? Decomposition reactions. Decomposition reactions. Now we will see, for example, AB. AB is the reactant and it is undergoing into decomposition, giving 2 products, that is A and B. Here AB is only 1 reactant, giving how many products? 2 products. 1 product is A, another product is B. Right? Now another example, ABC gives rise to A plus B plus C. Means here how many reactants are there? 1 reactants. But how many products are there? 1, 2, 3 products are there. Right? Next, another example, XY gives rise to X plus Y. Another XYZ gives rise to X plus YZ. It is also possible. In this way also possible. But to check here, in all cases, you have to check how many reactors are there. All these are general examples for the decomposition redox reactions. Decomposition redox reactions. Now just to check. Now just check here, how many reactants are there? 1, 2, right? Where? Sorry. In the first reaction, how many reactants? 1. Here, second reaction, how many reactant? 1. In the third reaction, how many reactant? 1. In the fourth reaction, how many reactant? 1. Means in all redox reactions, in all these reactions, how many reactants are there? 1. How many reactants are there? 1. Whereas how many products are there? Just check. In the first reaction, how many products are there? 2. In the second, how many products are there? 3. In the third, again 2, again 2. Means 2 or more. 2 or more. Sometimes it may be 3, it may be 4, it may be 5, etc. Now, such type of reactions are called as what? Decomposition redox reactions, or simply decomposition reactions. Right? Now, just to check, how many reactants should be there? Only 1 reactant. But how many products should be there? two or more products. Such type of reactions are called as what? Decomposition reaction. How to write the reactions? Definition is the reaction in which only one reactant, this one reactant undergoes into the decomposition and produces two or more products. Such type of reactions are called as what? Decomposition redox reactions. Or you may write as the reactions in which two or more products are formed from the only one reactant. The reaction in which two or more products are formed from the only one reactant. Such type of reactions are called as what? Decomposition redox reactions. That is only I am writing. Now first remember definition. Before that one I am writing one point. It is exactly opposite to that of combination redox reaction. It is exactly opposite to that of the combination redox reactions. Now we will see definition. Here I am writing the definition for the decomposition redox reaction. Now, how many products are there? Two or more products. But how many reactant are there? Only one. Right? That is only I am writing the reactions in which two or more products, are formed from only one reactant. Such type of redox reactions are called decomposition redox reactions. You have to remember two or more products but only one reactant. Such type of redox reactions are called as what? Decomposition redox reactions. This is the definition. Now once again I will write the general examples here. General examples for more clarity. I am giving the notes. This one, A, B gives rise to two products A and B, or A, B, C gives rise to the product A, B, C. X, Y, Z gives rise to the products X plus Y, Z. Means in all these reactions, if you count the number of reactants, only one. If you count the number of products, it may be two. First reaction 2, or in the second reaction 3. That is generally I am writing products are two or more. That is two or more products are forming from the only one reactant. Such type of redox reactions are called as what? Decomposition redox reactions. Now we will see the examples for this one. Examples for decomposition redox reaction. I am seeing the examples. Particular examples we will discuss. First example, right? Now here 2H2O gives rise to 2H2 plus O2, right? Now just check here, oxidation number of, here particularly oxidation number of hydrogen in this reaction is +1, oxygen is -2. Here in the reactant the hydrogen oxidation number is +1, right? And oxygen oxidation number is -2, right? Now here in this particular product, just check here, it is elemental state, only one element is there, therefore it is called elemental state or uncombined state, therefore its oxidation number is 0. Here also only one element is there, therefore it is called elemental state. Here also oxidation number is 0. Means here hydrogen oxidation number is changing from here in the reactant. What is the oxidation number of hydrogen? +1. 2. In the product, what is the oxidation number of hydrogen? 0. That is oxidation number of hydrogen in this particular reaction is changing +1 to 0. That is oxidation number is decreased. Therefore it is called as what? Reduction. Oxidation number decreases means that is called as what? Reduction. Now for oxygen, if you check the oxidation number of oxygen in the reactant, it is -2. Oxidation number of oxygen in the reactant is how much? -2, right? It is changes to 0, -2 to 0. Reactant oxidation number of oxygen in the reactant is -2 and in the product is 0. That is, it is changing from -2 to 0. Reactant -2, product 0. -2 to 0. Oxidation number is increased. Oxidation number is increased, right? Here oxidation number is increased means it is called as what? Oxidation. It is called as what? Oxidation, right? Now just check. Here it is. Oxidation number is increased for the oxygen and decreased for the hydrogen. Therefore, hydrogen undergoes into the reduction and oxygen undergoes into the oxidation, right? Now, here, this is the redox reaction. This reaction is a redox reaction. One element undergoes into the reduction, another element undergoes into the oxidation. Therefore, it is the redox reaction. Which type of redox reaction it is? Now, just check how many reactants are there? Only one reactant. How many products are there? Two products. One is H2, another one is O2, right? Therefore, it is called as what? Decomposition redox reaction. It is already redox reaction because hydrogen undergoes into reduction, oxygen undergoes into oxidation. Which type it is? It is decomposition redox reaction. It is only one reactant and two products are there. Therefore, it is called as what? Decomposition redox reaction. Now, we will see second example. Second example. Just check. Here I am writing the second example for this one. 2 KClO3 gives rise to 2 KCl plus O2. How many O2? 6 are there, means it should be 3. Now just check. Here I am writing potassium oxidation number is +1. Here also potassium oxidation number is +1. There is no change in oxidation number of potassium. +1, +1. Alkali metals always +1 oxidation state. Group 1, that is alkali metals. What is oxidation number? +1. There is no change. +1, +1 means potassium is not undergoing to oxidation. It is not undergoing into the reduction. Whereas Cl here, what is the oxidation number? If you check, -6 +1. Here it is +5. Oxidation number of Cl in this reaction is +5. What is the oxidation number of Cl in this reaction? +5. Whereas oxygen's oxidation number in this reaction is -2, right? Cl is +5. Here oxygen oxidation number in this particular compound is how much? -2. If you check the product, in the product Cl oxidation number is -1 and oxygen's elemental state oxidation number is 0. Oxygen's oxidation number is 0. Cl oxidation number is +5. Cl oxidation number is -2. Right? Oxygen oxidation number is -2. Oxygen oxidation number is 0. Right here, Cl oxidation number changes from +5 to Cl oxidation number is changing from +5 to -1. +5 to -1. That is, oxidation number is decreased. Therefore, it is called as what? Reduction. It is called as what? Reduction. Whereas oxygen oxidation number is changes from -2 to, in the reactant, what is oxidation number of oxygen? -2. It is changes to 0. In the product, what is oxidation number of oxygen? 0. Means oxygen oxidation number is changes from -2 to 0. -2 to 0 means it is increasing. Therefore, it is called as what? Oxidation. Here Cl oxidation number is decreasing. Therefore, it is undergoing into reduction. Whereas oxygen's oxidation number is increasing. That is from -2 to 0. Therefore, it is oxidation. Here Cl undergoes into reduction. Oxygen undergoes into oxidation. Here Cl undergoes into reduction. Oxygen undergoes into oxidation. That is, one element is undergoing into reduction, another element is undergoing into oxidation. Therefore, it is a redox reaction. It is a redox reaction. Again, which type of redox reaction? If someone is asking, just to check here, how many reactants are there? Only one reactant. Only one reactant. That is KClO3. But how many products are there? Two products. That is KCl and O2. KCl and O2. Therefore, which type of redox reaction it is? Decomposition redox reaction. Which type of decomposition? Which type of redox reaction? Decomposition redox reaction, because only one reactant and two or more products. Here two products are there. Therefore, it is an example for decomposition redox reaction. Next, we will go for the third one. Next, third one we are going to discuss, that is displacement redox reaction. Now just check. For that one I am using the rough paper. Try to understand here clearly. X plus YZ gives rise to, now before that one, X is one reactant, YZ is another reactant. X, how many elements are there? Only one element, that is X. That is which state it is? Elemental state or uncombined state. Only one element, that is called as what? Elemental state or uncombined state. Already we know that one, right? Here YZ, how many elements are there? Two elements. One is Y, another one is Z. How many elements are there? Two elements. One is Y, another one is Z. That is called as what? Combined state. Combined state, or it is also called as what? Compound. More than one element, therefore it is called as what? Compound. Only one element, that is called as what? Elemental state. Here more than one element, two elements are there, Y and Z, therefore it is called as what? Compound. Now just to check, X is displacing, just observe here, X is displacing the Y. X is displacing the Y, right? That is X is taking the place of Y. That is Y is replaced by the X. I can say that Y is displaced by X, right? Therefore what is the product? Just change the place, right? Y plus XZ, Y plus XZ. Which one is changing its place, right? Y and X, right? Which one is displaced? Y, because of X. Y is displaced because of X. Such type of reactions are called as what? Displacement redox reactions. Displacement redox reactions. Y is one of the atom. Y is one of the atom. Where? In the compound. Y is one of the atom in the compound, right? X is another atom, which is in which state? Elemental state. Which state? Elemental state. Now just check how to write the definition. Is when an atom in the compound, when an atom in the compound is displaced by the other atom. When an atom, Y is one of the atom in the compound, is displaced by the another atom which is in the elemental state. Such type of reactions are called as what? Displacement reaction. One of the atom in the compound, that is Y, displaced by the another atom, that is X, which is in the elemental state. Such type of reactions are called as what? Displacement redox reaction. If both X is also metal and Y is also metal, X is one of the metal M1, Y is another metal M2, right? Such type of reactions are called as what? Metal displacement reactions. Metal displacement reactions. Both should be metal. The one which is undergoing into the displacement, it is also metal. The one which is displaced, another one, that is also metal, right? Such type of reactions are called as what? Metal displacement redox reaction. If the one which is undergoing into the displacement, if it is hydrogen, then it is called as what? Non-metal displacement redox reaction. Non-metal displacement redox reaction. Now those are two types of displacement redox reaction. One is metal displacement redox reaction, another one is non-metal displacement redox reaction. That we will discuss later on. First we will write the definition. What is the definition? When the atom in the compound is displaced by the another atom which is in the elemental state, is called as what? Displacement redox reaction. That is only I am writing here definition. Definition, right? Now the reactions in which, or the redox reactions in which an atom in the compound, an atom in the compound is displaced by other atom in the, which is in the elemental state are called, or such type of redox reactions are called displacement redox reactions. What is meant by displacement redox reactions? The atom which is in the compound should be displaced by the another atom which is in the elemental state, and if it is the redox reaction, then it is called as what? Displacement redox reaction. Now we will see the general example. That only I am writing, already I wrote, that is only I am writing. Example, X plus YZ gives rise to, the atom which is in the compound is Y, displaced by the another atom which is in the elemental state is X, means Y is displaced by the X, gives rise to product Y plus XZ, right? Here it undergoes into the displacement It undergoes into displacement because of x, therefore it is called as what? Displacement reaction. If one undergoes into oxidation, another undergoes into reduction, then it is called as what? Displacement redox reactions. How many types are there? Two types. If both x and y are metals, if both, first one is right, if both x and y are metals, then it is called metal displacement reaction, metal displacement redox reaction. Second case is if x is metal and y is hydrogen, that is non-metal. Y is hydrogen, that is non-metal, then it is called non-metal displacement redox reaction. It should be redox reaction. Again, you have to check it is metal displacement reaction or non-metal displacement reaction. If x and y, the one which is undergoing into the displacement and the one which is displaces other, both should be metal, then it is called as what? Metal displacement redox reaction. If the one which is undergoing into the displacement, that is hydrogen, and the one which is displaces the other, if it is metal, then it is called as what? Non-metal displacement redox reaction. Now we will discuss one by one with example. First we will discuss about this is types of displacement redox reactions we are studying. Displacement redox reactions. In that first one we will discuss metal displacement redox reaction. Metal displacement redox reaction. First we will discuss. Now just check here, I am writing general example. First we will see the example, then we will go for the definition. First example, M1 is one of the metal and M2 is another metal. M1 is one of the metal and M2 is another metal. M2, let us take Z, M2Z. Now gives rise to M1 is displaces the M2. That is M2 is displaced by the M1. Therefore, what are the products? M2 plus M1Z means M1 is displacing the M2, or M2 is displaced by the M1. M2 is displacing M2, or M2 is displaced by the M1. Correct? Then the products are M2 plus M1Z. M2 plus what? M1Z. Now, such type of reactions are called as what? Metal displacement redox reactions. This is the general example. Both M1 and M2 are metals. M1 and M2 are metals. Now, next we will see particular example, or first we will write the definition. Next we will see the particular examples. What is the definition? What is the definition for metal displacement redox reaction? The reaction in which one of the metal atom in the compound, that is M2, one of the metal atom in the compound, that is M2, displaced by the another metal, that is M1, another metal, that is M1, which is in the elemental state, is called as what? Metal displacement redox reaction. What is meant by metal displacement redox reaction? The redox reaction in which one of the metal atom in the compound, is displaced by the another metal, which is in the elemental state. Which is in which state? Elemental state, is called as what? Metal displacement redox reaction. That is only I am writing definition. For metal displacement redox reaction, I am writing the definition. What is the definition is when, or you may write the redox reactions in which metal atom in the compound is displaced by other metal atom, not same, another metal atom which is in the elemental state, are called metal displacement redox reactions. Metal displacement redox reaction. The one which is displacing, that is also metal. The one which is undergoing into the displacement, that is also metal. Such type of redox reactions are called as what? Metal displacement redox reactions. Now we will see the examples, particular examples. Just observe the examples. First one, CuSO4 plus zinc gives rise to ZnSO4 plus Cu. I will write directly the oxidation number. Already you know how to calculate. Here copper oxidation number is +2. Here copper oxidation number is 0. That is, copper oxidation number is changing from +2 to 0. Copper oxidation number is changing from +2 to 0, means oxidation number is decreased. Therefore copper undergoes into the reduction in this reaction, and zinc oxidation number is in the product reactant is 0. Zinc oxidation number in the reactant is 0. In the product, if you check the zinc oxidation number, it will be +2. It will be how much? +2. That is, zinc oxidation number in the reactant is 0 and in the product is +2. That is, it is changing from 0 to +2. Oxidation number of zinc is changing from 0 to +2. That is, oxidation number is increased. Therefore, it is oxidation. Indirectly, the copper is undergoing into reduction and the zinc undergoing into oxidation. One element is undergoing into the reduction, another element is undergoing into the oxidation. Copper undergoes into reduction, zinc undergoes into oxidation. Therefore, which type of reaction it is? Redox reaction. Redox reaction. Here copper is displaced by the zinc, or zinc is displaces the copper. This is one of the metal, this is another metal. Here M1, M2, right? The one which is displacing, it is also metal. The one which is displaced by another metal, it is also the metal, right? Therefore both the metals are there. That is, copper is displaced by the zinc or zinc displaces the copper. Therefore it is metal displacement redox reaction. Redox reaction, because copper undergoes into reduction, zinc undergoes into oxidation. I will write another example. Example 2. Now just check. TiCl4 plus 2Mg gives rise to titanium plus 2MgCl2. Now if you check the titanium oxidation number in the reactant, here it is +4. In the product it is 0. Titanium oxidation number in the reactant is +4 and it is changes to 0. +4 to 0. That is, oxidation number is decreased. Therefore it is undergoing into the reduction. Magnesium oxidation number in the reactant is 0. Magnesium oxidation number in the reactant is 0. And in the product, if you check, it will be +2. Means it is changing from 0 to +2. Oxidation number of magnesium changes from 0 to +2. That is, oxidation number is increasing. Therefore it is called as what? Oxidation. Here titanium undergoes into the reduction and magnesium undergoes into the oxidation. Titanium undergoes into reduction, magnesium undergoes into the oxidation. Therefore it is the redox reaction. Titanium undergoes into reduction, magnesium undergoes into oxidation. Therefore it is the redox reaction. Which type of redox reaction? Here it is displacement, because titanium is displaced by the magnesium, or magnesium displaces the titanium. Therefore it is called as what? Displacement reaction. Again, which type of displacement reaction? Titanium is also metal, magnesium is also metal, correct? The one which is undergoing into displacement, that is also metal. The one which displaces other, that is also metal. Therefore it is called as what? Metal displacement redox reaction. Next we will go for the next one, second type in the displacement reaction. Second type, that is non-metal displacement redox reaction. Here one of the metal displaces the hydrogen. Metal displacement reaction, metal displaces another metal. Non-metal displacement reaction, one of the metal displaces non-metal, that is hydrogen. That is called non-metal displacement redox reaction. Now we will see the general example. General example. Now just check. M plus 2HX gives rise to, here hydrogen is replaced by the metal, or this metal displaces the hydrogen. It will form MX2 plus H2, means which gas is produced? Hydrogen gas, right? Hydrogen is undergoing into displacement because of this metal, or metal displaces the hydrogen. That is non-metal. Hydrogen is non-metal, which is displaced by the metal. Such type of reactions are called as what? Non-metal displacement redox reactions. Now we will see the definition. What is the definition? Is when the redox reactions, or the redox reactions in which the hydrogen in the compound is displaced by the metal atom which is in the elemental state. Metal, which state it is? Elemental state. Such type of reactions are called as what? Non-metal displacement redox reactions. Once again I will tell, just observe. the redox reactions in which hydrogen in the compound, it is compound, hydrogen in the compound is displaced by the metal atom, is displaced by the another atom or metal atom which is in the elemental state. Such type of redox reactions are called non-metal displacement redox reactions. That is only I am writing here. That is only I am writing here. Definition. Not focusing. Now just check definition. I want to write what is the definition is. Here it is not focusing, that's why I'm doing this one. Now the redox reaction in which hydrogen, here it is non-metal, is hydrogen in the compound is displaced by metal atom in the elemental state, are called, or such type of redox reactions are called non-metal displacement redox reactions. Hydrogen in the compound should be displaced by the metal atom. Such type of displacement reactions are called as what? Non-metal displacement. If it is redox, then it is called non-metal displacement redox reactions. Now we will see the particular examples. I will write 3 examples. First example 2Na plus 2H2O gives rise to, just check, Na is the metal and hydrogen is in compound. This Na is the metal which displaces the hydrogen. How we will see? It will give 2NaOH plus H2. Means H2 is separated from the compound because of Na, that is metal atom is displacing the hydrogen. Therefore it is called as what? Non-metal displacement reaction. Na oxidation number is 0, Na oxidation number is +1, that is Na undergoes into oxidation, hydrogen oxidation number is +1, hydrogen oxidation number is 0, right? Oxidation number of hydrogen is +1, oxidation number of hydrogen is 0, hydrogen oxidation number is decreased, therefore it is undergoing into reduction, that is Na undergoes into oxidation and hydrogen undergoes into reduction. Therefore it is a redox reaction. Which type of redox reaction? Metal atom is displacing the hydrogen or hydrogen is displaced by the metal atom. Therefore it is called as what? Non-metal displacement redox reaction. First example over. Next we will go for the second example. Second one. Here I am taking black pen. Second example. Example 2. Just check here. We will take 2 examples. It is enough. Zn plus 2HCl gives rise to ZnCl2 plus H2. Just to check here, zinc is the metal. Here zinc is metal. Here hydrogen is in the compound. Hydrogen is the non-metal and it is in compound. Hydrogen is in compound, right? Here hydrogen in the compound is displaced by the metal. Hydrogen in the compound is displaced by the metal, or zinc displaces the hydrogen, that is metal atom is displacing the hydrogen. Therefore it is also called as what? Non-metal displacement reaction. Whereas zinc oxidation number in the reactant is 0, in the product is +2. Therefore zinc oxidation number is increasing from 0 to +2. Therefore zinc undergoes into the oxidation. Whereas hydrogen, if you check here, oxidation number of hydrogen in the reactant is 0, right? Sorry, in the reactant is +1. Hydrogen oxidation number in the reactant is +1 and in the product is here +1 it is, in the product is 0. Hydrogen oxidation number in the reactant is +1, in the product is 0. That is, it is changing from +1 to 0. That is, it is decreasing. Therefore it is undergoing into reduction. Zinc undergoes into oxidation, hydrogen undergoes into reduction. Therefore it is a redox reaction. Again, which type of redox reaction it is? Non-metal displacement reaction. The one which undergoes into the displacement is a non-metal. Therefore it is called as what? Non-metal displacement redox reaction. Clear? Now next we will go for the fourth one, that is disproportionation redox reaction. Last one, that is fourth one. For that I am using another paper. last one, that is fourth one, that is disproportionation redox reaction. For that I am using next paper, that is now we will see. Fourth one, fourth main one, that is disproportionation. Here I am using complete paper, redox reactions. Disproportionation redox reactions. Now we will see. What is meant by disproportionation redox reactions. For that one I am using the rough paper here, rough paper. Now just to check, I am writing one of the example. For example, A to B, general example I am taking. A to B gives rise to A plus AB, A plus AB. Don't say that it is a decomposition reaction. It is also correct. Decomposition reaction, it is also correct, because only one reactant and more than one product, two or more product, correct. Therefore it is also called as what? Decomposition redox reaction. It is also correct. But observe, what you have to observe is here, for example, oxidation number, just for example, now let me take green pen here. For example, oxidation number of oxygen is here, right? Oxidation number of A in the reactant is 0. Just imagine, just think, just consider. Oxidation number of A in the reactant is 0. Here first product, its oxidation number is changed to -1, and in the second product its oxidation number changes to +1. That is A oxidation number, here it is 0, here it is -1, here it is +1. If you check from here to here, oxidation number is changing from 0 to -1. Oxidation number is changing from 0 to -1. That is oxidation number is decreased. That is from 0 to -1. Therefore we can say that it is a reduction. It is a reduction. Now if you say, check this one here, 0 to +1, oxidation number is changing from A, right? Here it is 0, here it is +1. That is 0 to +1. Here it is undergoing into increase in oxidation number. That is oxidation. That is oxidation. That is oxidation. Now just check here, oxidation number of A is changes from 0 to -1. It is for EA, right? That is reduction. Here if you check, oxidation number of A only, it is changing from 0 to +1. 0 to +1 means here in the first case, here it is undergoing into reduction. In the second case, A is undergoing into oxidation. That is the same element A, undergoes into both oxidation and reduction. That is only one element, that is A, undergoes into both oxidation and reduction. Therefore it is called as what? Disproportionation redox reaction. It is called as what? Disproportionation redox reaction. Means same element or only one element undergoes into both oxidation and reduction. Such type of reactions are called as what? Disproportionation redox reaction. Only one element. Just check from here to here, just check. A's oxidation number is 0, A's oxidation number is -1. Means if you check this one, you can say that A is undergoing into reduction because oxidation number is decreasing. If you check from A to A, this A to this A, right? Here oxidation number is A, here oxidation number is +1, oxidation number is increased. If you check this one, you can say that A is undergoing into oxidation. If you check the first reaction, you can say A is undergoing into reduction. If you check second one, you can say that A is undergoing into oxidation. That is same element A undergoes into oxidation as well as reduction. Such type of redox reactions are called as what? Disproportionation redox reaction. That is same element undergoes into both oxidation as well as reduction, right? Here there is no different element undergoes into oxidation and reduction. Only one element undergoes into both oxidation as well as reduction. Such type of reactions are called as what? Disproportionation redox reactions. That is only I am writing definition here. The redox reaction in which the redox reactions in which one element, right, or single element or same element, undergoes into both oxidation and reduction are called disproportionation redox reactions. Means the redox reactions in which same element or single element which undergoes into both oxidation as well as reduction. Such type of reactions are called as what? Disproportionation redox reactions. I will write the best examples. Just check it. Best examples I will write here. Examples. First example I will write 2H2O2 gives rise to 2H2O plus O2. 2H2O plus O2. If you observe, just observe here carefully, you have to observe here. Just check here, oxidation number of hydrogen is how much? It is a peroxide, right? Now here it is plus, right? For example, peroxide means, sorry, here it is -1. H2O2 is a hydrogen peroxide. Here oxidation number is -1. Hydrogen's oxidation number is how much? -1. If you check here, it is not a peroxide, it is water. Therefore here oxidation number of hydrogen is +1, right? Now for oxygen, if you check, -1 to +1, -1 to +1, leave it. Next, here it is, oxygen's oxidation number is here -1. Sorry, here it is +1 only, whereas oxygen's oxidation number in the peroxides is -1. Just concentrate on oxygen. Oxygen oxidation number is here -1, whereas here it is -2, whereas here it is 0. If you check the oxidation number of oxygen, just think, just once again I will repeat. Here it is H2O2 is a hydrogen peroxide. In the hydrogen, here oxidation number is +1 only, right? Sorry, here it is +1 only, whereas oxygen's oxidation number in the peroxide is -1. We have discussed already. Oxygen's oxidation number in the peroxide is -1. If you check here, it is oxidation number is -1. Here it is oxidation number in the water of oxygen is -2. Oxygen's oxidation number in the water is -2, whereas it is elemental state, its oxidation number is 0. Here, if you check here to here, here it is -1 to -2. Oxidation number of oxygen is changing from -1 to -2, -1 to -2. Therefore, if you check here, you can say that oxidation number is changing from -1 to -2. That is, it is decreasing. Therefore, it is reduction. If you check from oxygen here to here, first to last, right? It is changing from -1 to 0. Oxygen only. Here it is changing from -1 to 0. Therefore, oxidation number of oxygen is increasing. Therefore, I can say that it is oxidation. Here reduction is there, oxidation is there. Therefore, it is a redox reaction. But both redox reaction is because of only one element, that is oxygen. Here oxygen undergoes into both reduction as well as oxidation. Therefore, such type of reactions are called as what? Disproportionation redox reaction. This is a disproportionation redox reaction because same element, that is oxygen, undergoing into both oxidation as well as reduction. Therefore, it is an example for which reaction? Disproportionation redox reaction. Next, we will take another example. For that one, I am using another paper. Now, another example, second example. Just check a second example. Cl2 plus 2OH minus gives rise to ClO plus Cl minus plus H2O, right? Now just check here, just check, right? Now here oxidation number of Cl is here 0, whereas oxidation number of Cl is here, it is -1, right? Here it is, sorry, oxygen is -1, here Cl is +1. If you check the oxidation number of Cl, here it is +1, right? Now if you check the oxidation number here, ion means -1, means here check, just check here, Cl oxidation number is 0, here Cl oxidation number is +1, Cl oxidation number is here 0, here Cl oxidation number is +1, means oxidation number is increased from 0 to +1, 0 to +1, oxidation number of Cl is increased. That is, here Cl oxidation number is increased from 0 to +1. Therefore, it is called as what? Cl undergoing into oxidation. Now if you check here to here, from this reactant to this product. Here 0 to -1, here to here it is reta -1, here to here it is -1, 0 to -1. Cl oxidation number is changing from 0 to -1, means oxidation number 0 to -1, it is decreased. Therefore it is called as what? Reduction. Means here Cl undergoes into both oxidation, Cl undergoes into both reduction, right? That is Cl undergoes into both oxidation and reduction. Therefore which type of reaction it is? This reaction. Which type of reaction it is? Disproportionation redox reaction. Why it is called disproportionation redox reaction? Because same element undergoes into both oxidation as well as reduction. Both oxidation as well as reduction. From here to here it is Cl undergoes into oxidation. From here to here it is Cl undergoes into reduction. That is, if same element undergoes into both oxidation as well as reduction, such type of redox reactions are called as what? Disproportionation redox reactions. Clear? Now this completes your types of redox reactions. Now we will stop here only. Thank you.